Hey everyone, Mr. Newman here, and today we're going to pick up another video on modeling with quadratics. This time we're going to use what we know about factoring and the quadratic formula and use that knowledge to better calculate the parabolas that are modeling our situations. So let's get started. First of all, I want you guys to, we're going to work on this top left and top right, bottom left and bottom right. So we're going to start by factoring this equation. So I need to find factors of -5. The reason it's -5 is because it's -1, which is in front of the x squared, times 5. So we have 5, a -1, and -5, and 1. The ones that add up to 4x are 5 and -1. So I'm going to put this in my box. Let's see here. -x squared is kind of bizarre, but we're going to write it like that. And 5 goes in the bottom right. Then 5x and -1x go in the bottom left and top right. And factor out the GCF. So x, a 1, -x, and 5, which means my factors look a little bit different. There's x plus 1 and there's -x plus 5. Those are the factors of the equation. So we want to write our equation like that. To calculate the zeros, that is when the y value, or f of x, is equal to 0. So we write our factors out and we say equals 0. Then we know we can set each factor equal to 0. So 0 equals x plus 1, or 0 equals -x plus 5. Now over here we get x is -1. I ran out of room, so hopefully you can write a little smaller on all of this than I can. And we solve for x. X is not by itself. We need to divide by -1. And 5 equals x. So the two zeros are x equals -1 and x equals 5. Next question is, what do the zeros represent? Well, they represent when y is 0. In other words, when the height is 0. Now that makes sense for one of these two, but it does not for -1, because that's to the left. So only x equals 5 is the 0 in the situation. So what do the zeros represent? Well, x equals 5 is when the height is 0. So I'm going to put that in the table. We'll fill out the table kind of as we go. The point is right down there, 5, 0. Because when you plug in 5, you get a 0. Now something to note is that the line of symmetry is halfway between the two zeros. So whenever you find both zeros, -1 and 5, if you look at halfway between those, that's going to be the line of symmetry. And that makes sense because the line of symmetry is when the whole parabola is symmetrical, and so anything that's on the left has to be on the right, and so the line of symmetry is going to be halfway between those two zeros. So the way you find halfway between 2 points is you add them together and divide by 0. So I'm going to add -1 and 5 together and divide that by 2. Sorry, did I say divide by 0? I meant divide by 2. So 4 divided by 2 is 2. That means the line of symmetry is at x equals 2. So I'm going to sketch that. So let me draw -1, 0. Even though it's not a part of the situation, I'm going to draw it just so we see that our line is that halfway between those points. And sure enough, yep, we could have probably eyeballed that and said, oh yeah, that's right between them. Now, find the maximum based on the line of symmetry. What's nice is you always know that the maximum or minimum always goes through the line of symmetry. Since the line of symmetry is the x value, we can plug that into the function and get out a y value. So we plug in the line of symmetry, or the x value of the line of symmetry, and find out what is the y value. Well, when you do that, let's see, 2 squared is 4. -4 plus 8 plus 5 equals 9. So the point is 2, 9. I'm going to plot that point right up there at the top. Okay, and I'm going to write it in the table as well. Last thing we need to do is, how high did the ball start? Well, that's when the x value is 0, because that's the start of the throw. So we're going to plug in 0 into our function. When you plug in 0, you get 5, which means that is, I'm going to put that as a point on the table and on the graph. And notice I left some space here. That's because I want to fill in the rest of the table to match the situation and to match the graph. So I did give you guys the right number of spaces here. It's not always important that those line up, but you notice if we find a point on the left side of the line of symmetry, the same point should show up on the right side. So if that point is 2 away from the vertical line, that point should be 2 away from the vertical line. And you could plug those in, like I could plug in 4 and calculate it and get 5, but it's a little faster to use the line of symmetry as we're sketching it. You plug in 1 up there, you're going to get 8, and that means if you plug in 3, you also get 8. Now that we have our function, let's connect the dots. Notice I'm not going to connect to the left because that is where the throw starts. And what we did here, you guys, is we actually graphed the function without a graphing calculator. So this was actually the same function we did before, except I gave you guys most of the table and I gave you the graph. We were able to do this just calculating the zeros through factoring and by this little trick of the line of symmetry being halfway between the zeros. That is a pretty nifty thing to know how to do, and that is what you're going to be asked to do on the quiz. Let's go on to the back and see another kind of situation where you will need a calculator, but again, we're going to use our knowledge of zeros to calculate it instead. So, here a soccer player uses their head to hit a ball up into the air from a height of 2 meters with an initial velocity of 5 meters per second. The height h in meters of the ball is given by this equation, where t is the time elapsed in seconds. So, first thing I ask you to do is use the quadratic formula to find the zeros. So you have to identify A, B, and C. And now we start in the quadratic formula. So negative b plus or minus b squared minus 4ac all over 2a. You can type all of that into a calculator. Make sure you put it on a fraction bar or put the whole top in parentheses, otherwise it won't divide out correctly. And when you put in the plus or in minus, let's see, for one of them, I believe for the plus, you get negative 0.307. And for the minus, you get 1.328. Those are the two zeros that you can type into the calculator and get out from the quadratic formula. So how long will it take the ball to hit the ground if no players touch it? Well, it's one of those two numbers because those are the zeros, and it has to be 1.328 because time must be positive. You can't have a negative time in a situation like this. Now, in order to calculate the Linemen Symmetry, we need to add those two together and divide that by 2. When you do type that in a calculator, you get 0.510. Again, the maximum is based on that value, and that is a t value because that is time, so 0.51 seconds. At 0.51 seconds, that must mean that is the height of the maximum height of the ball. So let's plug that in for t, and you get 3.276 meters, which is the height. So what I'm going to do here on this table, I've got a lot of data. I'm going to plug in, and we know t is time, that's our input, and we know h is height, that's the output. I'm going to put in certain values. So I know it's going to start at time 0. When you plug in 0, you notice you'll get a 2 out because the t's are all go to 0. And I'm also going to plug in the time it takes to hit the ground because that's the end of the situation. That's 1.328 we figured out. And I'm also going to put 0.510 because that's the maximum height. I'm going to just put that somewhere between 0 and 1.328. And we calculated that maximum height to be 3.276. Now, for the rest of these values, I don't care what values exactly you use as long as you spread them out. So I'm just going to pick some values to use. It looks to me like 0.2, 0.4, then 0.6, 0.8, and 1.0 are good values to be nice and spread out. You might want to use 0.8, 1.0, and 1.2 instead. Whichever set you use is fine as long as they're somewhat spread out. They don't have to be perfectly spread out, just somewhat spread out so we have a general shape to graph. I'm going to use the calculator to calculate the rest of these, and I can show you guys how to do this using a table. Is much faster. But each of these you can plug into the calculator and you get out a value. And notice now I've got my table filled out. For the graph, you want to write your axes, and we need to label our axes, and it's very important to look at, okay, what's the smallest time and the largest time? 1.328 is the largest time, so I know if I go from 0 to 1.5, that will both fit the data, and the data will fill the graph very nicely from left to right. I wouldn't want to go somewhere large like 10 seconds, because then my graph will be all scrunched over to the left there. Also, for the y-axis, I see that 0 is the lowest number, and 3.276, that was the maximum. So I'm going to move it like this. We could do 1, 2, 3 and leave a little bit of space. I think the top there would be 3.75, so that is above the 3.276. Again, you don't have to do exactly this, but I know that this graph will now nicely fill the area. So, h is height, t is time. Make sure that your axes are labeled, r is r. And we're going to plot points. So 0, 2 is a point. 0.2, 2.8 is a point. Another thing I did was I made every step to the right is 0.1. So 0.2 is easy to find, 0.4 is easy to find, 0.5, there's our maximum, and then we start coming back down. Again, I'm not being super precise, but I'm just marking these as well as I can, and our final point is 1.328, is somewhere around there. So I'm just going to connect all of these dots with a curve as best as I can, and now we have the ball. One last thing I'm going to do is I'm actually going to draw the line of symmetry there, just so you can see, hey, the ones on the left and the ones on the right should be about the same. Now, I drew it pretty much right on 0.5. It should be just a little bit to the right of 0.5, but it's so small to the right, I can't mark it accurately. So you want to make sure you draw that as accurate as possible. But, okay. So, thank you very much for watching.